Good morning or afternoon or wherever you are. For me, it's afternoon. And we're going to talk about conic sections, one of the key concepts. You've learned how to graph parabolas. You've learned how to graph ellipses and circles and hyperbolas if you've been doing the work along. And now we're going to look at those functions, considering the general second degree equation of any conic section. Remember, conic sections are the intersection of a plane through a double napped cone. So if it comes straight across, the intersection would be a circle. Circle. If it comes at an angle to the side of the double nap, you're going to get an ellipse. And if it comes at a steep enough angle so it's equal to this side or this side, you're going to get your parabola. Because I should have put it down here so we have a smiley face. And finally, if it intercepts both with the angle greater than this angle, then it's going to be the hyperbola. Okay. It's got the circle, the ellipse, parabola, and the hyperbolas. And they all have equations. And the general version of the equation, get ready for this, folks. Get ready for this. All right, here you go. It's a monster. I'm going to zoom in on it so you can see it in the close-up version. Okay. This is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. That's your general version of the general second degree equation for any conic section, for any of those four, for an ellipse, a parabola, a hyperbola, circle. Okay, so then we have to figure out, we're going to use that equation, that form, to figure out which kind of conic section we're talking about. And there's this trick, not a trick, it's a mathematical fact, okay, to identify the type of conic section you're looking at. Use this thing called the discriminant, okay, b squared minus 4ac. That may sound familiar, b squared minus 4ac, because in b squared minus 4ac, when we had them in small letters, little b and little a and c, we were talking about finding the discriminant for a parabola, for a quadratic function, okay, b squared minus 4ac. You might recall that we did, if you had, say, x squared plus 3x plus 5 equals 0, we could use our discriminant. A would be 1, B would be 3, and C would be 5. And we go 3 squared minus 4 times 1 times 5. And that would tell us what type of roots we have. In this case, it's a negative number, so 2 imaginary roots. Yeah, so that was that discriminant when we were talking about quadratics. Here we're doing something different with it. You notice that the letters are all capitals now, and they correspond with the capital A, the capital B, and the capital C. And notice that this A is always with the x squared, this B is always with an xy term, and the C is always with the y squared. Okay. We'll worry about the D, E, and F later, but for this part, this is the most important part, those three things. And now, how do you tell the difference? Okay, this is where you got to be crucial. In your textbook on page 653, it's hard for me to show you right now, it lays this all out for you. Oops, get back into focus, dominocus. Okay, so here we see, we got these 4 conditions, okay? 4 conditions for our 4 conic sections: the circle, the ellipse, parabola, and the hyperbola. 4 different conic sections, 4 different conditions. Let's look at those conditions carefully. Notice it's all talking about this discriminant, this b squared minus 4ac, and always starts with the b. Remember, the b is the xy term. If you see an xy in there, then you have a b, otherwise b would be 0. Okay. Keep that in mind, it's very important. It makes this understanding easy. Notice also these symbols, both of these say less than. Okay, so if this thing comes out like in that example I just did, if our discriminant came out to be something, where did I put it? Less than 0, then on this conic section thing with these complicated long equation, ax squared bxy cy squared dx eay plus f, that tells us that we have either a circle or an ellipse. Okay. And we'll know we have the difference by these other two factors. Okay. If the b squared minus 4ac is negative, okay, and the b is equal to 0, and there's no xy, and the a is equal to c, okay, then you have a circle. Similarly, if your b squared minus 4ac, your discriminant is negative, and either you have a b number that's not equal to 0, or your a is not equal to c. There'll be two different numbers. Okay. The 4x squared and the x squared term and the y squared term will have different numbers. That would make an ellipse. Okay. So circle and ellipse, you know you got one or the other if it comes out b squared minus 4ac turns out to be negative, less than 0. You know you have a parabola if you do that b squared minus 4ac and it comes out to be exactly 0. Okay. If that were a discriminant on our parabola and it came out to be exactly 0, what you'd be saying is that parabola is touching the x-axis. Whoa, that's not a very good x-axis. The parabola is touching the x-axis in one place. But since now we know we can do parabolas sideways, we can do x squared equals 4py, it could be touching the y-axis in one place. Okay. B squared minus 4ac equals 0. Okay. That's for a parabola. Finally, for your fresh, brand new friend, the hyperbola, you'll know it if that discriminant comes out to be greater than 0. There are a couple other ways you would know it. Okay. Because as you remember, the circle was x squared plus y squared equals r squared. The ellipse was x squared over a squared plus b squared over y squared over b squared equals 1. And the parabola was either x squared equals 4py or y squared equals 4px. And the hyperbola is the one with the minus sign in between things. It's the only one with the minus. So that's a big hint as to how to do these problems. One other little fact to remember is when b is equal to 0, that means your axes are horizontal or vertical. Okay. Horizontal or vertical. They're either horizontal or vertical. So everything we've been doing so far, our axes have been horizontal or vertical. All the ellipses you've drawn, all the circles you've done, any parabola you did, any hyperbola you did. All our axes were either vertical or horizontal. I mean, all of them had b equals 0. That's going to be important. Let's see what happens in the next little piece. Hold your horses. Okay, in the book, you will see that there's some crazy things that they're going to have you do, and I'm going to show you part of it right here. Okay. As you may recall, when we studied parabolas, that we could transpose them, translate them around the x and y axis, okay, with that h and k number. Okay. We can do the same thing with all these conic sections. Circle, if you change the h and k, that's telling you where the center of this new circle would be. Okay. It's translated this many units on the x-axis, h units, because h minus h makes 0, so h units, and k units on the y-axis to get to a new center. Same is true with parabolas. A slight difference though in that, you have the y minus k squared, 4p x minus h. So again, it's the h and the k are shifting. In this case, it's the vertex that gets changed. The vertex. Here it's the center, here's the vertex, and the other two, it's also the center that's being moved with this h and k, h and k, h and k. There's a Desmos activity I'm going to put up And you can play around with it. It's more for just intellectual stimulation than for anything else, which is what we really want to do if we want to learn. We want to stimulate our intellect. And I'll put that up there, and that's why I'm showing you this. So you can see that if you had to write an equation and your center is not at 0, 0, then you have to figure out what this h and k thing is. Okay, more on that later. Okay. So the thing I really want you to know how to do, however, has to do with the general form of the equation. Okay, so I'm going to write some down here. Okay, so oops, wrong page. I'm going to start you with where I want you to go and then take you back a step to another way to get there. So for this exercise, the minimum thing I want you to be able to do is to A, classify conics from their equation, and B, write the equation, transpose the equation, transpose general form to graphical form. This is getting a little bit long. We're up to almost 12 minutes, but bear with me. We're almost through it. Okay, so first off, let's look at something straightforward. Minus 2y squared plus 24x plus 2y minus 1 equals 0. So we look at this thing, we say, okay, let's get our a and our b and our c. Well, a is the number multiplying x squared. B is the number multiplying xy. Oops, number multiplying x squared, so that's a 6. B is the number multiplying xy. Do you see an xy term? There's no xy term, so b is 0. That tells us something right away. And then c is the number multiplying our y squared. So we can see that our discriminant is 0 squared minus 4 times negative 2 times 6. Should have gone 6 times negative 2 for AC. Okay, so we can see it's going to be a plus. That's going to be 8 and 6, 48. So that means it's greater than 0. Okay. If our discriminant comes out to be greater than 0, then we have a hyperbola. And another way that we could have seen that really quickly is that's a big indicator, that minus sign. Zoom in a little bit. That fact that there was that minus sign there, it's a big hint. It's not always true, because sometimes there's other minuses that'll cancel it out, but that's a big hint to let you know that that's going to be a hyperbola. But that's just using the discriminant. And you can do that with any of these funky little equations. Okay. So let's look at the other part of this. Okay, transpose the general form to a graphic form. This is a little more involved. Okay, I might actually make a whole separate, in fact, I think I will make a whole separate video on this, but I'll take you through one right now. Okay, so the process involves using what's called completing the square. We have to regroup our function. So we got x squared minus the 14x plus the y squared plus the 4y minus 11 equals 0. Then we're going to move that 11 across to the other side, so it's going to equal 11. And we're going to look at this thing and we say, okay, well, we can turn this into a square. But it's by remembering that to make this a perfect square, we need half of this number. 14 divided by 2 is 7. And we'll square that number. So we have 49. Okay? Plus the y squared plus the 4y. And what's half of 4 is 2. 2 squared is 4. But then we've added these two numbers, these 49 and this 4, we've added them on, so we have to add them on to the other side. And I'm running out of space on my page, 49 and 4. So now I've got, not only is it equal to 11, but it's also equal to 49 plus 4. So 11 plus 49 is 64 we've got there. And now we can rewrite this as a perfect square. X plus, excuse me, that's got to be a minus, negative 14, so it's minus 7 squared plus, here we've got a y plus 2, because 2 squared is 4, and 2 plus 2 makes 4, equals 64. And what kind of equation is that? That is a circle centered at 7, negative 2, with a radius of 8. Okay. All right, that's enough video for today, for this moment. That'll get you started, and I'll make another one to show you more on how to do these problems and what you're doing them on. I think I wrote this into the book, probably haven't, onto Google Classroom. This is page 656, and you're doing from 28 to 44, and you try as many as you can. The more the merrier, the more intellectually challenging you can become, the better you'll get at this stuff, and it'll give you something to do. All right, see you soon. Bye.